Good morning. I would firstly like to thank the organizing committee for this conference to invite me as a keynote lecturer for the application of AI and computer vision for geotechnical engineer. My name is Sompoth Chiwai. I'm from Thailand. I'm Department of Civil Engineering from King Mongkut University of Technology, Chonburi. So the contents of my topic actually is composed of two parts. The first one I will talking about the current AI or artificial intelligence and COV computer vision technology right now in the world. Firstly, I will intro about the deep learning. What is the deep learning? I will show you about the example of the deep learning, about the regression and classification problem, and talking about the current platform because right now in the world we have a lot of I have to say it's free platform and it's really excellent. You can use it for free. And the next part I will talking about the computer vision. What is the computer vision? How can it work? What is the OpenCV library? What is the YOLO classification of the picture by using YOLO? YOLO is that you only look once. And the next part I will have some of my work and my research group about the how can we use this application to the geotechnical engineering. First part talking how can we obtain the size of the particle by using this technology, and we can use the computer vision for perform the settlement monitoring or supervision for bridge or bridge infrastructure and so on for the infrastructure. And we can use the AI for get the soil profile from boring log. And also I have some example about how can we use the AI for pile supervision, and can use the YOLO, you only look once, to get the pavement distress, where is the damage to your pavement, and you can count from the we can use only the mobile phone, take the video and send into the server or computer. You can get where is the distress in your pavement. And the last part I will talking how can we predict the pile behavior in Bangkok area by using AI. And last one I have the conclusion about the AI. The first part I have the quote from Bill Gates. He said a breakthrough in machine learning would be worth 10 Microsofts. Why worth 10 Microsoft? Because if you can let the computer learn by itself, it can create a lot of program. Because right as before we have, when we try to create a program, we have to set up the flowchart, and we spend a lot of time, have to use a lot of people to do it. But right now we can use the computer to do it. So that means right now we have a lot of application in AI. So firstly, we're talking about fundamental of neural network. What is neural network? I will show you one example. How can it make? How can it calculate? So the neural network, they composed of the node here, node. This one starting with input layer, can be several types of the layer. Maybe there should be some number, maybe 2, 4, 7, 6, something like that. And you would like to predict maybe 1, 2, 3 is the output layer. Maybe 1 is cat, 2 is person, 3 is bicycle, for example. This one is a classify problem. Classify problem is that you have the input layer of the picture, and you can classify that what is the output of the picture, something like that. Okay, so the way we do it, we have the sum up of the weight. Each line contains weight, and weight. Okay, how can we sum up? For example, we use the 1 multiplied with weight, go to this way is 4 multiplied with weight, something like that. So that means one node we have to sum up of the Oh no, this one is from, have to have source from ibm.com, and we have to sum. So I will show you how can it work. If we have this example, they have only maybe only input here and output over there. Okay, so the input should be 1 0 here. So how can we sum up to this node? Okay, how can we sum up? So how can, here it should be 1 multiplied with 3.7. okay, 1 multiplied with 3.7, sum to this node. And the next one is 0 multiplied with 0 times 3.7, and the last one is 1 times minus 1.5. we combine something like that, and when we combine it, we get about 2.2. After we get the 2.2, we have to send this value into a so-called activation function. Actually, they have several kinds of these functions. So today we use this function is so-called sigmoid function. Sigmoid function is something like this. It's 1 over 1 plus exponential power of this value. So I send this one into the sigmoid function. So finally the value is about 0.9. Okay, that's correct. So we just change this one into 0.9, and the other one here we do the same. We use, sorry, I've changed the number. Okay, we use 2.9 multiply with 1 here, 0, okay, doctor here, 0, 2.9, and last one is minus 1.5. we sum up it here to be, we put into the sigmoid function, this one equal to 0.17. okay, so that means we send into the inner layer of the neural network is 0.9, 0.7 and 1, and we sum up again with the weight here, we can get the output. Okay, it's something like that. We sum up, it is about 0.9 times 4.5, 0.17 times minus 5.2, this 1.2, so this add into the sigmoid, so equal to 1.17, and the last one is 0.6. this one is the input, and last one is the output. Okay, so for example, but if you try to predict some of the problem and it found that the output that you want is about 1, so what should you do next? You should change the weight. Maybe you have to change the weight here until the result is close to 1, or maybe have some certain error that you want. So we just change this weight from 4.9 to 4.8, change this weight also, change this weight also. We have to update also and back propagate to change this weight, okay, to change it until they have the error reduced to certain value as you want. So how can we change the weight? They have the technique is so-called back propagation. I'm not talking for detail today, because right now the program, the platform is really good. It can do for you. It's no need for you to do it by yourself. If you change the error until the target and the result is the same. So this one is so-called, in neural network, it's called retrain network. Or if you are some type of research, some kind like you try to the curve fitting the curve fitting with the parameter. Change the parameter. So you can see it here how many parameters in this program. Have 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 9 parameters. Or that means this model you change 9 parameters to fit the result of the network. So right now, actually, it's as before, maybe 20 years ago or 10 years ago, you have to do it by yourself. But right now, they have really awesome platform that can do it for you. So the next part, I will show you how can it work. I have some example from so-called from TensorFlow. I will show you how can it classify the problem. You open this link, it's a playground tensorflow.org. It be something like this. So first I will show you how can the neural network can be work. So we start with x1 and x2. x1 is the first, this one in data science we call feature. So this means we have two feature x1 and x2. One here, x2 here, and we like to classify the results to be the blue one or to be orange one. If we talking into the matrix, maybe we can the blue one is 1, the orange one is 0 or something like this, or 1 and 2 we have to classify. So firstly, if the result something like that, x1 here, x2 here, we would like to classify. We have two input layer for neuron, and they have the two neuron, and we classify. Let's just see. Okay, you can see now it's finished. You can classify with the blue one, and we have the orange one, and we have the weight here. Weight is 1.6. Weight here is minus. So you can see the weight is sent into the two neuron. We can increase maybe to 5 neuron, and we can increase. See what's going on. It can be classified also. Okay, and they have the training data loss, they train, and the test data. We split the data into two groups, and we test it. If we change to be the more complicated, this one we like to classify this one. Is it work or not? Okay, so that means this network is quite effective. It can classify x1 and x2 two feature and as something like this. If the final result is something like this, you see here, this one is quite simple way to classify it. It change to be this. This one is really complicated results. Should be the blue one, should be the orange one. You can see it's work or not. You can see this architecture of this network is not work at all for this type of data. You can see they have still really high error or high loss. Even we train it really long time, it's still lost. So that means what should we do? We have to do something. We have to add. Maybe add a lot of neuron. Okay, we have to add to be deeper and deeper. You can see is it gonna work? Look better. When you work with neural network and you try to train it, it should be something like this. To train it and it's just like working. It's like try out error to see what's going on. You can see the result is still is not good. So what should we do next? Maybe we just add some of the feature with x squared, x2 squared. Okay, it's work or not? It look much better. So it's the feature and engineering is work. You can see they have some noise. Okay, and I add everything. Okay, look smooth. So that means this one I can classify with something like this. If I change activation function to be sigmoid, I don't know it's work or not to see the sigmoid. Sigmoid is not gonna work for this problem. Or maybe to Lilu. Lilu is quite good one also. Change activation function. It's still not gonna work. So the best one is sigmoid. Sorry, it's not sigmoid. The best one is 10H, as you see before. So this one is example how can we work with neural network. We have to select the best architecture for it, and let's train it. Computer is try to train it and try to reduce some of the error to your system. And when you train it, you get the if this one is satisfy your condition, you train it. After that, you can save your network, and you can use your network to predict the other problem as you want. Right now in the world, we have a lot of platform for AI, and the really good news, if you would like to use it, it's free and open source. You can use it for your work without any kind of subscription or payment. You just know only maybe C++ or Python. You can use it. You can order it to do for you. So right now they have a lot of the number of AI platform. The one that people quite popular to use is TensorFlow. And you have the Keras, PyTorch, Cafe, Piano, CN, Cafe 2, Channel, Fast AI, or maybe some of Darknet. You can use it for your training platform. You can order it by someone is to use. Commonly, you can use the Python to control it. And firstly, the TensorFlow is come out from Google, and people complain that it's quite difficult to use it because you have to write a lot of things to train your network. So they have the Keras. Keras is open source software library that provides a Python interface. Use the Python interface for AI. Keras acts as an interface for TensorFlow library. So if you use Keras and TensorFlow, is quite easy to use. You can write really short command to let TensorFlow to run it for you. So most of my project I always use Keras because it's quite easy to use and can reduce my time to writing a code. And actually they have the other open source AI is from Facebook. Now it's really popular. It's so-called PyTorch. Torch, that means you have the torch. You can create the light from Python. PyTorch is an open source machine learning library based on Torch library, and you can use it. It's really good for computer vision, natural language processing, and it's primarily developed by Facebook AI Research Lab. If we compare, this one is the Google trend. I just get it yesterday. The trend of using the PyTorch and TensorFlow, I think firstly is 2020 the PyTorch, the popularity is lower, but right now it's quite the same, and it shows some trend that PyTorch is higher than TensorFlow. Why people like to use the PyTorch but instead of TensorFlow? Because it's flexibility of PyTorch is more than TensorFlow and easy to use. You compare, and it's always get the good result for image classification. The training time is quite fast, and also when you write some AI, somehow you have to train it. Maybe spend really long time. Sometimes it's maybe 2-3 days, or some if you have a lot of database, maybe 1 week. You have to use the cloud service. One cloud service that I always use, I would like to recommend you, if you're the new one for writing, use the Google Cloud Service. It's by the Google and it's free of charge. You can write the code and you can run it on the Google, And the Google Cloud Laboratory is you can link with Google Drive, and you have 12 hours free of running time. So that means you training your network in 12 hours is free. If you would like to train it more than this, you have to buy to be the Google Cloud and run it, and it's free for CPU support. This one is really fast. Even I have my MacBook Pro, the top spec at my home, even the speed is same as in Google Colab. So that means it's no need for me to invest for the new computer for neural network. And the other one is from Google also, is so-called Kaggle. Kaggle is same as the Google Colab. You can run the code, you can add the data. This one is actually they developed this one for data scientists. It's not the coding you can run. In Kaggle, you have, it's like a social network. They have competitions, such as you have the G research in crypto forecasting. You can see how can they forecast the crypto. If you is expert in data science, you can get the money. You can see it's a really big amount of money, 100,000 USD if you won the prize. Or you have around the cell instance segmentation. This one they have the money also if you can do it. It's just like a league for the people to do it. And it's not only for Kaggle, it's not only the competition. They have a lot of free courses. Some course I learned from this one. I get a lot of that detail from this one. It's only a course that you have a lot of forum. You can see the code, and you can maybe just, for example, copy some of the path to run on your code. It's really fast to learn. So that means for machine learning right now, currently it's really easy to learn. You can learn it from your computer and has a lot of examples to see what's going on. So firstly, I will talking about application of unsupervised learning. I try to use unsupervised learning to use in my geotechnical engineering work. First application is that if I have this one is a so-called boiling log. It's a soil layer in geotech. They have the sample type, they have the depth that you collect the sample, and you have so many things. The routine work that the engineer in the office, they have to divide the soil into layer by layer, have to grouping, and it's depend on the engineering, and it's a way not the same. So I have me and my undergrad student during his internship in the COVID situation. You cannot work outside, so we work together to produce this one. How can we writing some code for divide soil to layer by using AI? So we use a so-called K-mean. K-mean is algorithm that identify K number of centroid. You have to check the centroid and allocate every data point to nearest cluster by keeping the centroid small as possible. The means in K-means refer to averaging the data, that is finding the centroid. So this means they try to change the centroid and to find the best classifier of the data. So I use the K-mean and use the elbow method to classify the soil data. And also I would like my student to practice. I also put this one into the so-called the web app. I write the app and then run on the server, and they just upload the Excel file. You can get the result. If you would like to use my web app for the soil profile classification, you just go into this one, soilprofile.hurikuapp.com. This one is a free app, so sometimes it's quite slow, so please be patient. So after that, you have to upload the Excel file. You can download from the example from my Excel file. They have the sample number. You just put the heading the same as my file. They have water content, gamma, passing number 4, liquid limit, plastic limit, SU and N. You can use your soil data and just put into this. If you have this Excel file or your Excel file, you just choose the file and put the file here, and you just upload your file. Wait for a while, because as I told you before, it's a free server. So this one is finished. This one I use the k-mean with elbow method to classify. So you can see the first layer is really soft gray, SU equal to this. Second layer is soft gray, medium gray, hard gray, and hard gray. And they have the, if the gray have the SU value, and group for the unit weight. You can try it. Actually, it's only a starting point of my version. Actually, I like my students to train to use it and to see how can they classify the soil. If you have any kind of feedback, you can go to my Facebook here, okay, Civil Engineering Online here, and you can give me some of the feedback, or you can contact to me. This part I will talking how can we apply the deep neural network for regression problem. Regression problem is that we would like to predict something by using the neural network. So this one is my project during COVID. Also I stay at home, so I try to develop this one, actually do it by myself. In Bangkok area, we use a lot of pile to resist the load from the bridge, from the building, and so on. We have a lot of database for the pile loading test. But right now the problem is right now we still have to test it, and the cost for testing is really expensive. This one is the last pile, is the ballot pile. The cost for static testing, I think, is about almost 1 million baht per one test. So I will try find a way to predict it. So the result is something like this. Is there should be the load acting on the pile. This one you can see the load is really high, 4,000 tons, and have the settlement of this pile is about 73 millimeter. So I try to predict it. So that means I have to keep the load and let the neural network to predict my settlement. And the problem is that in Bangkok area you have a lot of maybe different kind of pile diameter. It can be very small one, it's about 0.5, maybe somehow it's about 1 meter, or maybe somehow it's about 1.5, or maybe it can last up to about 3 meters. So I will try to use the same network for predict all type of pile. You can see that this one is the result. It's the width of the pile, the height of the edge, the height of the pile is not the same. And if you see the result of the pilot test, because you have different kind of pile, so that means the loading on this kind of database is not the same. The high loading is can be up to about 5,000 tons with testament about 125 millimeter, or in some pile is smaller one. So I will add all this curve into the deep learning and how can predict. So you can see that firstly I have to do a so-called feature engineering. Feature engineering, same as I show you, is x1, x2, and so on. So I try to use this feature to predict. First feature is length of pile. N is the SPT, or the value of the stiffness of the soil or strength of the soil at the base. And there is the starting to collect the sample in Bangkok to use the split sample, and the depth of medium clay and the depth of the steep clay. This one is the feature that I will try to train it in neural network. And also I will input the value, the N average. N average is the average value of SPT value. So I adding this one and have to train it. And this one is the distribution. This one is length. Distribution the base. This one is the count. So let's see what's going on if I use this feature. Actually, it's like some kind of trial and error. I try out so many times, and see what is the best. This feature actually changed so many times out, so maybe firstly the feature is more than this. I reduce the feature to be something like this. So this one is one of the example. This one is not unpublished result, we publish in the journal soon. So let's compare to architecture. When we work with the neural network, we have to prepare a so-called architecture. This one is the type of the node, so-called LSTM, long-term short-term memory, and something like this. And I have to so-called look back. So look back is mean if we would like to predict this point, okay, and I have to look back so many steps to come. If we look back only one, so I use only one step on the load. I look back only 2 or 3, I look back to each loading. So you can see that if I use the look back about 1, I get the absolute mean error is about 11.14. I think it's quite nice for me. I think if we get the error only 11%, I think it's quite good compared to I try to use finite element. Right now it's more than this. And also they have the new method. Also I use the so-called convolution neural network with the max pooling and followed by SGM. It can find that the error can reduce up to 8.45%. So right now if I do something like this, that means I have the model for pilot test. That means when I input the value of the soil in the other side, in the other place in Bangkok, depth medium clay, depth of the SS is the depth of the steep clay, and average and base. The error that I expect, I can predict the result is the error is not more than 8%, and the error is calculated by using the K4 method. Okay, it's a long story to tell you. If you like to know what is a K4, you can see in the literature. So you can see that it's not look too difficult. You just use the tool, you just change the architecture of the neural network. You can predict or regression. You can generate the piloting test in Bangkok area. Actually, I spent maybe 2 or 3 months. Only 2 months I can finish this work. This part I will talking to you how can we train or can we let the computer to see, or so-called computer vision. So if I will show you how can computer see. So this one is get from the source from carcoops.com. is to see how can Tesla car see the road. And see that they see the lane, the line for the lane, left or right, or you can locate the what is the car here, what is traffic light, and autopilot has to stop at the intersection, okay, and go and turn left. So before it can do like that, they have to locate where is the car. Can locate in 3D. It's really good system. It's not in 2D. It can locate in 3D. It can locate the lane. It can locate the everything. You can see it here. The distance from your car to the other car without any kind of lidar, without any kind of laser. Is really, I have to say that now the computer is really clever. And the one that made this learning is really awesome. You can see it here. And stop here. It's not only how to drive, you have to locate it first. So what is the computer vision? Computer vision is the field of AI that enables computer and system to derive meaningful information from digital image, video, and other visual inputs, and takes action or make recommendations based on that information. If AI enable computer to think, computer vision enable them to see, observe, and understand. So same as our brain from the eye and can process in the brain, and can see that is the bowl, orange, banana, lemons, and peaches. Computer also, you get the sensing device from the camera input and into the interpreting device on your computer, and have to recognize that this is the bowl, orange, banana, lemon, peaches as the output. Is the classification problem. Have to, so this one is really good protocol, good platform to see it. So how can computer to see it? Computer didn't see same as the human. Is something like this. Computer see in the metric form or in the tensor form is the number here. This one is level of the grayscale. And change into this. Computer see something like this. And if you train the computer should know that this is what is the face of Abraham Lincoln. We just say, okay, this is Abraham Lincoln. So we have to train computer what is the matrix here is Abraham Lincoln. Or you can see from the cat here, small part of the cat is the number something like this. So image classification should be 82% is cat, 15% is dog, 2% is hat, and 1% is mug. So this one is that how can we train. And before we train, somehow we have to process the picture first. I have the popular or my popular library, so called OpenCV. I will use it to do something. Or if you use the Photoshop, this one is style Photoshop to maybe to make it sharpening, to create some of the line. If you change the computer to be this, something like this, I think it's quite easy to recognize more than this matrix, something like that. So in my research, I always use this one also. I will tell you later on. And the first one I have to look back about, because it's this conference emerging technology, I have to talking about history first. How can we classify the picture? It starts from Alex Kerpchevsky, is somebody called AlexNet. He published the paper and he won the prize. He won the image recognition competition. He had this paper ImageNet classification with deep convolution neural network, and he proposed a so-called convolution neural network to classify what is the mite, what is container sheep, motor scooter, leopard, mushroom, cherry, and so on. And before the computer can recognize what is type of the picture, they have to train it with several kind of the picture. What is the convolution neural network? And COV is some kind, like we have a torch here. Okay, we have the torch and try to lighting the torch to see some portion of the picture here. So we become 4 into 1. So we create the other matrix. So that means the matrix will be smaller. So you have the torch to see several parts of the picture. This one, and change the convolution neural network. And after that, you pooling torch and pooling, and using the torch also and pooling. After that, this one is so-called feature engineering. That means this feature is you can use it for classification. And after that, you send this feature into the deep neural network here, and you can classify. This picture is car, truck, van, or bicycle. In AlexNet, you have about 9 layers of convolution, pooling, convolution, about 9 times, and some of the network will be more than 100 times. It depends on the network that you want. More complex is maybe you can get the best result, but you spend a lot of time to train. Maybe you have a lot of parameter to training. Somehow maybe parameter of this net maybe more than 1 million parameters to training. And after that, when you classify it, you come to is so-called YOLO. YOLO is so-called you only look once. That means you look only one time. They might have some problem is that if they have several things in one picture, the dog is not contain all the picture. The dog contain only some part of the picture. They have the bicycle. They have the car. How can you classify? So in 2017 they have the paper. I liked this paper so-called YOLO 9000. He said better, faster and stronger. Inside the paper they said what is the better than the other one. Faster is so fast and stronger. You only look once. How can it make? They divide the image into a grid. Each grid has its centroid of the grid, something like this, and they find this grid is dark or not, gray dark or not, and after that they combine it of each grid. Bounding box confidence, and they show this one is a dog, something like this. And the YOLO is really fast. It's outperform the other. It's faster than RCNN, faster than fast RCNN. This one is really fast. It's really actually really simple, easy thinking, but it's fast. And the YOLO, you can see it here, same as I talking about you before. They divide into the one charm, and after that they look at it and they combine it after non-mass separation. As this one is said that is the car. The technology of YOLO, or you see only once, is really fast. And this one is the lecture from the TED Talk of the Redmond. He talking about his technology YOLO, and actually I like it very much. I would like you to watch it, to listen to him, and it's a time that the technology can be changed our world.
Turn down our threshold for detection a little bit so we can find more of you guys out in the audience. Let's see if we can get these stop signs. We find some backpacks. Let's just zoom in a little bit. And this is great, and all of the processing is happening in real time on the laptop. And it's important to remember that this is a general purpose object detection system, so we can train this for any image domain. The same code that we use to find stop signs or pedestrians, bicycles in a self-driving vehicle can be used to find cancer cells in a tissue biopsy. And there are researchers around the globe already using this technology for advances in things like medicine, robotics.
You can see it here. This one, he proposed YOLO version 2. This one is YOLO version 5. This one is really fast. I run this one on my mobile phone. And this one is my son, is the park. You can see this one is person. It's here. It's not on my iPhone. You can see it's really fast. It changed a lot, you know. Even 1 year I changed from the computer to be an iPhone. According to the YOLO right now, if we some idea, we have the iPhone that attached to your car, and you can observe the outside, what's going on outside the car, and use the YOLO and use the PyTorch as the neural network classification, and you can use the YOLO version 5 object detection. And this one actually I have the concept of one competition. They try to use a road detection competition, they would like to try the crack of the road. They like to use only mobile phone to take the photo from the car, and after that they use the YOLO or the other method to detect. And this one is the 00 is the longitudinal crack here, and the 10 is the transverse crack. Transverse crack is on the other way. This one D0, and the 20 is alligator crack here, and the 40 is the pothole. Pothole should be around here. Pothole. It might be nice if you can detect it. So I use the previous network and result, and use the result of Thailand and try to train it. So this one is a result of the road in Thailand. You can see the YOLO technology is can detect the pavement really well. See it here, they have a lot of pothole. This one is not good road condition in Thailand. Even the quality of the video is not quite good. It still can detect. So actually right now it's cannot real time. I record the video and then after that I detect it using my computer to do it. Okay, this one in Thailand. If we do like that, okay, you can, if you can train it with the result from Thailand data and world data, and after that you can detect that this one is, for example, is kilometer. Maybe you can see that they have some damage. How many damage on the road? If you see how many damage on the road, you can see you can determine the road condition, and the highway department or department of highway in Thailand can see how much damage on the road, what is the crack of this road, and they can set the planning of the road. That means it's no need to use really sophisticated machine or method. You have only one mobile phone. You can do this thing. You can detect the road damage. You can sum up the road damage. If you have the server type, you can do it quite real time. People at the highway department can see what's going on off the road. And the next part, I will talking how can we use a so-called AR. AR is the augmented reality. It's not metaverse. Metaverse is on the other world, like Facebook is the VR, virtual reality. AR is try to put some image into our world. The AR that I use is that I try to locate the target. Okay, this one is one type of target. It's called ARUCO. It's one of target. I have the camera and I take the picture of this one. I know the size of the target. I can determine the distance or the vector from the camera to the target. It's not only the vector of the camera to the target. I can rotate. I can see the rotation of this axis represent to the camera also. So this one is my student. He used the so-called ARUCO. Is one type of the target detection. This one is published by Francisco. It's so-called paper is speed up detection of square fiducial markers. Or is ARUCO. Okay, so this one is work of my student. He located about the 4 target and he moved 1 target and see, and he calculate the difference between 1 target and the 4 targets. This one undergrad student, my undergrad student. Okay, they can see the difference of this target to the other 4 target by using some of the vector. see it again. So that means if we put this target into this one that we would like to monitor, maybe the road or bridge or maybe some of the pile, we can monitor the behavior of it without any kind of analog thing. Analog thing is LVDT, linear variable different transducer, to have data logger. This one they can use the computer to see what's going on. The first one that I use this target and computer vision, that I in the COVID situation I cannot do the lab. This lab is so-called particle size distribution. I have to put the soil in the sieve and then see the size. I would like to know the size of the soil passing through the sieve, and we have to plot the grain size of the particle and the percent sieve fraction, the total in sample that the soil is retained on the sieve, and we have to plot this curve. If we do in the lab, it spend maybe some 1 hour or whatever. We have to send the soil to the lab. So I have this idea, how can we use computer vision to do this lab? And I like my student to do it at home, to get the soil at home and test this one at home. It's no need to come to university. So firstly, I have my idea is I have the A4 paper and put the soil in. Soil is maybe sand and so on, and try to distribute it, something like this. And after that, I detect this AIUCO and determine the size of AIUCO in pixel. After that, I distortion correction. This one is still distort, change to be the square, change to be the grayscale, and use OpenCV to change this picture as adaptive threshold to be something like this. And after that, use AIUCO. Should computer is OpenCV or CV2 to find the contour. It's like this. The computer will find the contour, and use this one. You can know the size of the particle. You can know the width. View 2, you can know the width of the sample. But when you know from this one, you know in pixel. You have to transfer the length, the number of the pixel into the length by you have to reference to AIUCO parameter in pixel. So as I mentioned before, you detect this one into the pixel, and after that you can change this one into the real length. For example, you print this one, maybe I don't know, maybe 10 centimeter. So you get this parameter is pixel ratio is AIU parameter in pixel divide by the actual AIUCO parameter. You have the pixel ratio, and after that you get the actual width of the soil particle by using the width pixel average by divide by the pixel ratio here. You can get the D here. So I let the computer to determine the D, or the average size of the particle in each of the particle. And after that, we can plot this one immediately. Is the number of particle size, and this one is the final. It's not only this. You can classify. This one is the program to classify what is the soil type, what is the file content here of the soil, or this one what is the CU and CC. So that means right now, if we go to the site, we have only one A4 with the target here. You press the soil on the A4 and you take the photo by iPhone. Actually, I have the app on iPhone also. Take the picture. You can obtain the particle size distribution immediately at the field. And if you interest about this, I will show you what is a web app. How can you do it? I also provide this app I write in Python, and I I develop it to run on the web is so-called web app. So how can you use it? You just go to this one and you upload this file, upload to this one, and you upload your image, and you see it's run for a while because it's the free server. It takes time for a while to run it. So that means we send the file to, and after that the result is something like this. They have the grain size analysis, they show the soil type, they show the file content and classification, and also they have the picture to download what's going on with your soil. You can try it, and you have, if there any feedback, you can send the feedback to me. The application of the target, we can, as I mentioned before, we can put it, we can attach it at our structure or something that we want to measure. This one is the senior project of my undergrad student. They try to attach the target AUCO to the pile and record the pile driving. You can see here, you can record the last 10 rows of the pile. In Thailand, the practical way, we have to put some staff to sit here and record by the paper. This one, you just put the target on the pile and use only one mobile phone and tripod. You can monitor the pile driving immediately. And also it can extend to the more complicated method, just as you can, if you have the really high frame rate camera, you can measure for the dynamic pilot test. Also you can measure for the strain also by using this method. And it's not only this. So this one is our pilot project. We would like to monitor the bridge approach structure. This one is the bridge. Here, this one is a bridge. This one is bridge approach structure. They have some settlement will occur at the bridge approach structure. If we put some of the marker on the parapet of the bridge, and we use only mobile phone or one camera to take the picture, we can obtain the difference or the movement of the bridge by this target, and that target. So that means the one staff of highway department is go to the site with one mobile phone without any kind of tripod and take the picture, and it can process immediately what is different between this target and can be compared with the previous measurement what is different in the settlement of this bridge. It can save the cost without any kind of instrument. And it's not only the bridge, you can install this one onto the maybe the building or something that have the high settlement and can monitor the settlement, or even we can set the server to monitor it real time also. So for the conclusion of my lecture today, I talking about the fundamental of deep learning, talking about what is the platform for deep learning is the free of charge. About the computer vision, what is convolution neural network, what is you look only once, AIUCO target concept, and also the application of use this technology to geotechnical engineering projects such as particle size distribution, settlement monitoring, pavement distress, pile driving supervision, and piloting test. And there are also the quote from Jeff Bezos that AI is a golden age and solving problems that were once in the realm of sci-fi. So that means you can see that if we go back into 30 years or 40 years ago, right now the application of the AI computer vision is same as we watch the movie in the cinema. Thank you for joining my presentation.